So today's topic is multi-objective linear programming problem. So what do you understand from the name? Yes, you have more than one objectives. So earlier what we have constraints, but we have only one objective. Multi-objective means you have more than one objective. Suppose you go for a car, you want to purchase a car, right? What you say? That you want to maximize its average, right? You want to minimize the cost as well. And some persons say that the engine capacity they want to maximize, right? So they have more than one criteria to select an article, right? Some constraints are there that your budget is this, right? And you can go for loan only for this period, and this should be the installment. So that can be the constraint. But in this, what we have more than one objectives, right? So what if we have more than one objective, like linear programming, जब हम general problem लिखते थे, वो क्या हो सकती है? The objective can be maximized or it can be minimized. It can be one function, that is z1, right? कैसे हो सकता है c1 x1? Because this is linear programming, that means we have linear everything. So that can be c1 to x2, right? c1n xn. You can have second objective, that will be your c2 1 x1 plus c2 2 x2 plus c2n xn. And suppose you have k objectives, right? So this is ck1 x1 plus ck2 x2 plus ckn xn. And the one thing that you have constraints, right? So constraints can be a1 1 x1, that what we write a1 2 x2, right? And a1 and xn. The constraint can be less, can be equal, can be greater than the right hand side b1. Similarly, second constraint, and the second constraint can have anything, right? The mth constraint am1 x1, am2 x2, and amn xn, and the sign of inequality can be anything, right? And you have xi's are greater than equal to 0 for all I is equal to 1 to n. So this is the general multi-objective linear programming problem in which you have more than one objective. The general example we have, suppose you have three subjects, right? You have one subject is you study theory of computations, right? One you study optimization technique, and suppose one you study software engineering. So you want to maximize your marks in every subject, that in the theory of constraints, that in the theory of that is optimization technique or software engineering, right? Some students have secured the marks, that is the constraints, right? So how you will say that which student is better and which student is best? क्योंकि कईयों के theory of computations में marks ज्यादा है, कईयों के आपके optimization में ज्यादा है, theory of computation में कम है, कईयों के software engineering में ज्यादा है, software engineering में कम है. So when you have multi-objective linear programming problem, then you have more than one objective, so that it might difficult to say which is best, right? Optimal solution जब हम कहते हैं, optimal तो होता है ना कि that is the best solution from all the solution, because it satisfies your objective function, that it has maximum value at some particular point or it has some minimum value at particular point. Then you can say that is my optimal solution and this is the best solution from all the solutions. But if you have more than one objective, how you can say that this is your optimal solution? So the example we can say that I have already told you, that you have, suppose one objective is maximize marks in, right, theory of computation, maximize marks in optimization technique, maximum marks in software engineering. Suppose this you have objective, right? Subject to, you have constraints that the marks secured by student 1. I'm just taking 2 students just to compare that how it is difficult to identify. Marks secured by student 1 in TOC, suppose this is 50, and in OT this is 60, and in suppose software engineering it is 65, and suppose marks secured by student 2 in theory of computation, suppose this is 65, marks secured by student 2 in optimization technique, that is 60, and marks secured by student 2 in software engineering, that is your 50. Now if you see from here, you have 2 students. We have student 1 and student 2, right? And on the other part, we have 3 subjects: theory of constraints, optimization technique, software engineering. इसमें कितने मार्क्स हैं उसके? 50, ठीक है, 60, 65, and we have 65, 60, 50, ठीक है. So अगर हम चेक करें who is better from 2 students, who is better? If we talk about theory of constraints, कौन सा better है student? Those who, because when we are identifying on the marks basis only, so that you can say student 2. And in OT it is 50, I think. In OT it is 65, 50, 60. Okay. So it is 50. So in this we have student 1 is better than the student 2. In this again we have student 1 is better than the second student. Now you have said this. If I ask what is best, can you tell? So it is very difficult to identify when you have more than one objectives. ठीक है, जैसे मैंने आपको कार की भी एग्जांपल दी, that you have want to maximize the average, you want to minimize your cost, and you want to maximize suppose the engine capacity. ठीक है, तो अब कई कार में कुछ अच्छा है, कई कार में कुछ अच्छा है, किसकी कॉस्ट ज्यादा हो रही है, एवरेज ज्यादा रह रही है, कम रह रही है, ठीक है. तो दैट यू हैव, दैट मीन्स यू हैव टू सेटिस्फाई समवेयर, राइट. So what you can do, we can convert multi-objective into a single objective. How we will convert? We have, you can do it 2 ways, that you can take the average of your objectives. X1 में जितने elements हैं उनका average ले लो. Number of elements divide by total of elements divide by number of elements. Or you can say, if you have weights assigned to this, जैसे अब आपके सारे सब्जेक्ट्स हैं, बेस्ट या जो आपकी फर्स्ट पोजीशन होल्डर होता है वो कैसे चुना जाता है? That you have CGPA for that. That means for every student wants to maximize his or her grade in every subject. ठीक है, बेस्ट कैसे चुना जाता है? That you assign grades to some subjects. So for example, suppose I am giving 5 credits to the subject TOC, and if I am assigning OT subject, suppose I am giving 3 credits, and software engineering I am saying suppose 4 credits. So now what you can calculate? You can calculate the average CGPA, right? Average marks, or you can say average marks of student 1. कितने होंगे? That you will sum up these terms with the credit. Now you will multiply, right? You can't just sum up. अगर ये credit नहीं given होते, मुझे simple objective में करना होता तो मैं क्या करती? Just I'll add 50, 60, 65. I have 3 elements, divide by 3. So average marks will be, suppose I have credits of 5. That sometimes these credits here we are calling the weights, right? So the first objective carries the weight 5 credit. Second objective carried 3 credits. Third objective carries 4 credit weight. So 5 into 50 plus 3 into 60 plus 4 into 65 you have total weights is 5 plus 3 plus 4, right? Again, for the student 2, what you will have 50 into 65, 5 into 65, sorry, 3 into 50 plus 4 into 50 divided by 5 plus 3 plus 4. So this is coming out to be your 57.5 and it is coming out to be your 59.58. Now, can you tell who is best? Second, right? So you can see, जब आप better की बात कर रहे थे, तो student 1 2 place पे आ रहा था. That does not depend. Now it is depending on the weights which you are assigning, right? So who is best? So student 2 is best. So when you will assign weights to your objective function, then you can convert your multi-objective into single objective. ठीक है? उसके बाद वाला प्रोसेस तो सेम ही है. सिंगल ऑब्जेक्टिव में कन्वर्ट हो गया. You have constraints. You have one function, maximize or minimize. One more thing, when you want to convert your objective into single objective, तो या तो सभी को maximize में convert करना, जितने भी आपके objectives हैं, तब आप उनको weight और average देना, right? Or you can convert it into minimize. पता है ना कैसे करते हैं हम? अगर minimize होता है तो we will multiply with the negative sign. The function will convert it into maximize, or if you want to convert it into minimize, just the vice versa, multiply by minus sign, it will convert it into your maximize function. Is this clear? The rest remains same. If you have equal to constraints, you can go for bigger method. If you have all constraints are less than, you can go for simplex, or if you have equal or greater, you can either go for two-phase method. Is this clear? Yes or no? One more definition is that is the efficient solution, or you will have, that is mentioned in your syllabus. Suppose we have one objective, maximize 2x1 plus 3x2. We have minimize x1 minus x2. We have third objective, maximize 3x1 plus 2x2. जैसे आप पहले नोटेशन देते थे, you can give it z1, z2 and z3. We have three objective and one constraint, x1 plus x2 less than equal to 1, and x1 and x2 are greater than equal to 0. Since it is in two variables, so what we can use? We can use the graphical method. So we can use the graphical method. If I draw this constraint, you can do this. The function, it will come 1 as 1, 0. The points it will come, and 1 will be your 0, 1. And if you will combine, join this by a line, this is our line. And what will be my feasible region? The inner portion we will have feasible region. And what are my boundary points here? So that all are my feasible solution. So feasible solution मेरे क्या आ रहे हैं? 0, 0, 1, 0 and 0, 1. So now we check the objective function, because I have to tell you one definition, efficient solution and efficient frontier. That's why we are not converting into one objective, right? So one is, we have first objective, right? We have 2x1. The objective is 2x1 plus 3x2. One objective, we have x1 minus x2, 3x1 plus 2x2, and we have 0, 0, 1, 0 and 0, 1. So what are the objective functions value? So at 0, 0, my this value will be 0, 0 and 0. At 1, it will be 2. This is 1 and this will be your 3. And in this, you will have 3 minus 1, 2. ठीक है? अब अगर हम मैक्सिमम या मिनिमम की बात करें, ठीक है, ये मेरा ऑब्जेक्टिव फंक्शन मैक्सिमम का था, तो आई हैव मैक्सिमम वैल्यू इज दिस वैल्यू, राइट? एंड इन दिस, at this point, this is my minimum value and this is my maximum value, right? Objective function is maximize, ठीक है, मैक्सिमाइज वैल्यू मेरी किस पे आ रही है, 0 2 3 दैट इज 0,1 एंड दिस इज मिनिमम, सो फर्स्ट एंड सेकंड की आ रही है 0,1, ठीक है, और थर्ड ऑब्जेक्टिव की किस पे आ रही है मेरी वैल्यू, that is 1,0. So you are getting two efficient, that means you are getting two solutions. Are you getting my point? So this is my first objective is maximize, second objective is minimize, third objective is maximize. तो पूरी रो में मेरी मैक्सिमम वैल्यू इस पॉइंट पे आ रही है, सेकंड के लिए भी मेरी -1 पे आ रही है और थर्ड के लिए मेरी इस पे आ रही है. दैट मीन्स these two solutions which we got, इन दोनों पे ही वैल्यू आ रही है, 0 0 तो पॉइंट पहले ही हट गया. So these two solutions, I am saying these are my efficient solutions, or you can say non-dominant solution, or non-dominant solution. अगर आपके पास, जैसे हम वहां पे कहते थे कि अगर मेरे पास दो सोल्यूशन आ जाएं, ठीक है, ऑप्टिमल सोल्यूशन, तो आप क्या बोलते थे, इफ यू हैव मोर देन वन ऑप्टिमल सोल्यूशन, then the line that is the CLC of all those points, that will be also your efficient solution. That means if you have 2 points, that will be a line because it is your problem. So that can be, you can say curve, or the line which will pass through your these points, that will be your efficient frontier, we call that, right? So efficient frontier is a line, or you can say a curve. When we have LLPP, linear programming, we will always have line, right? A line or curve that is the CLC of that passing through, or that is the CLC that passes, that is the CLC of efficient solutions, is your efficient frontier. In this example, A1 10 plus A2 0 1 on the condition that A1 plus A2 is equal to 1 and A1 A2 greater than equal to 0 is your efficient frontier. Is it clear? ठीक है. So this is all about your multi-objective linear programming problem. So you have this introduction that what is multi-objective is different from single objective, and what the method, you can see the average, or you can go for the weights if weights are given to you for particular objective, and then the efficient solution and efficient frontier. So this is all about your linear programming, multi-objective linear programming problem. Fine.